Welcome back, everyone. My name's Wim. Again, I'm the track host for the automation track, and I'm very excited to present you with Nikolaj Tolkaciov. Tried to pronounce his name correct. Um, just like me, Nikolaj believes that IT is for lazy people. Why do things yourself if a computer can do it for you? And I think from that perspective, he's a big fan of test automation. And maybe that's also the reason why Nikolai didn't prepare any slides. Nikolai, he wants me to do an interview with him. So, Nikolai, maybe before we start the interview itself, you can present yourself.
Yeah, sure. Thanks for presenting me, Vim. Is it? Yeah. So I'm Nikolaj Tolkaciov. I'm a testing practice lead at Debridge, a Cognizant Soft Vision company, and I'm also one of the co-hosts in Pokalbė apie kokybę podcast. And yeah, today I'm going to be talking about full stack test automation, where you have to look at different separate layers of automation as a one like general view how we can utilize and make it more efficient. So yeah.
Yeah. I noticed that the test automation track is rather popular. A lot of people are looking into it, but do you think there are any problems with the current test automation approach?
Yeah, I did notice some of them, and I have actually a full list. And from automation perspective, we're probably I need to make a small disclaimer that all the things that problems I'm going to be like mentioning, it might not be a case in your specific project because everyone is doing something a more of a custom way approaches. And yeah, you might have all of the problems, you might have none. And if you don't have any of the problems I will be mentioning, that's great, you're on a good track. But I probably want to start with unit testing. And there's one big issue with unit testing that they are driven by code coverage. And that might sound really good because you can cover all the code and it makes sense. But there's a really big issue with that. If you have a code application which you want to like do unit testing for, and you have code coverage, you can create a test which covering 100% of application and is passing. So it's great results. But the problem is that you don't even need to have requirements to do that. You don't need to have all the like specification user stories what the business wants you to achieve. You just need the code and then the code coverage. So basically it's a bit of an issue because you might run into problems when you don't actually test what functionality is required. Then you can have 100% coverage passing, all the tests are passing, and the application is not doing anything what it's supposed to be. It's doing everything like in the wrong way. There are some miss requirements and some things that not even working as expected. And that's the problem with your unit test is if you only follow unit test as a code coverage, you can run into those kind of problems. And this is a kind of a big issue. And one of the ways to solve that is to use test-driven development. So you write the test first without writing a code. And if you have that, if you need to write the test first, you only source you can use is not the code. It's actually requirements. It's actually user stories. You need to use that in order to produce a test, which you then write the code for. And this is actually a good way to do that, and the most efficient way actually. And people are like using that sometimes, but it's quite tricky to actually nail the test-driven development. And some just skip that part because it's too difficult. And that's what makes the implementation details from a code is actually leaking into test cases. And that's why we are writing a test unit test for the code to make sure the code is and skip the part that what is about the business is the business requirements are met. And this is what I seen in practice as well. It's quite a difficult and like a kind of a big issue actually. And I think every time when I hear that the teams are using code coverage to drive their unit test, I think that like it's not the best way. And yeah, this is something that's actually happening and it's hurting the industry. If we move to another layer, we have integration tests, and integration tests are bigger in the scope. For example, if you have unit tests, they're kind of small. You're probably testing one class. If you think about integration test, this is more of like a bigger one. If you think about microservices, it could be the whole microservice. It could be some kind of like a big module. If it's a monolith, a big module of doing something specific, like all the price calculations happening in this module. So basically, you will write like integration test for the whole module. And the problem with that is that they're kind of expensive because you need to have all the places, all the dependencies working. You need to have everything in place in order to write that automation, like write integration test. And usually developers are skipping them. You then don't write them and they use unit test. And the worst case, if we use not a unit test, but we use like some sort of integration test, but with a lot of mocking. And I actually seen some of the cases when there is like a controller, which is have some kind of functionality to call multiple functions from different classes in order to get like the data enriched with all the information it required. So you get something from database and then enrich the data and send it back to the user. What happens there that at the first call to the database, you basically mock that. And what happens with the mock is that whenever you want to like ask the function to return you some kind of value, you're not calling that function. You just like mock engine just saying that, okay, the counter, how many times you call this function is like +1. So you call that function, and then you can specify what kind of answer it's supposed to give you back, which one with one you're going to be working with. That answer doesn't have any kind of relationship with the actual result what that function will be giving you. So you basically, if you have integer, you need to return integer. You might return string, and it wouldn't even like give you any kind of error. It could happen, and the problem with that is that it's usually outdated. So you have this like mock data which you expect the application to give you back, which might not even be actual results, and you give it back to the function, so to that like controller. What happens next, then you have another call and you use that mock data to ask for another, like call another function. And in return, you get another mock, which is like not even used, that data you sent, it's not even used, and you get back another mock. So basically you do all these functions, like call all the functions, you don't do any kind of value. You have only mocks, you work with the mocks, you don't even know what kind of results you have. And at the end, you could make an assert that it seems like it's done, it's tested. But in reality, that doesn't bring any kind of value. And if you write that kind of like test, you probably shouldn't even waste time because it doesn't give you any kind of information if the application is working or not. And even maybe if you have some kind of requirement, the quality gate that you need to reach specific code coverage, and if you didn't reach that, it will not allow you to pass on to commit, like push that feature to the like development or another branch. So you need to create that coverage, and you basically write just anything to have that coverage, even though it doesn't give you any value. And this is actually problems which we encounter in the projects, and this is how developers are working with that. Another thing, we as a test engineer don't really know that UI, like client side, also have a very good unit and integration test. And all the modern frameworks like React, Angular, and Vue, they have this capability. They can write unit and integration test, and you can test UI before you even need to write any kind of end-to-end test. So imagine if you have a page with some kind of form, you can like work with one module. So basically you work only with the form. You don't need any kind of login. You don't need like footer, header, side menus. You don't need that. You just work with the form. And what it allows you to do like validations. You can do all that, like error handling, some kind of errors, maybe specific JavaScript logic that if you put some kind of heavy like check mark on some of the like input field, more input fields like appear. Like if you have like, for example, a secondary address, and you can like more fields appear. All of that logic can be tested with unit and integration test on the client side. You don't need to write expensive end-to-end test, UI end-to-end test to actually test it. So usually that part is kind of missed. And there is another thing that contract testing. And basically, if you have a front end, you think that if I create some kind of like required fields and I click send button, I will not be able to actually test if it's working with the backend. And you can create a contract for it. And basically, whenever you click on that unit test for front end, you make a test case where you send the form with your input fields. You can create a contract which is tested against that your what you're sending. And if it's matching, that means the contract is still valid. And basically this will be what front end will always send to the back end. Well, at least field types, how many fields, what the names of fields are, values doesn't matter that much. And then from a backend, you can also integrate into that contract and basically saying that this is a payload I receive via API endpoint, and can I work with that? Is all the fields are in place? Can I return the specific answer to that contract? And this is how you can integrate backend and frontend without ever deploying it anywhere. So you basically have a contract, and then unit tests are integrating into that contract. From one side, it's assert what the results are, and from another one, it's a payload for the data I'm going to be using for a test. And this can help you actually reduce even more how many system tests you can have. And this is basically, you don't even need to deploy it anywhere. You just have them running as a unit test. So basically on a build machine, they're quite fast and really responsive. So that's a really good case for microservices environment, but also good case for if you have a backend and front end. So then we're going to another realm, which is now responsibility is passed from developers, because the ones I'm just mentioned is a developers kind of test. They are writing and responsible for them. And we move to another realm, and we go to API and end-to-end testing. And this is where test engineers or any kind of QA is starting to take responsibility. And we don't really care or know what's happening before. So we basically assume there's nothing written, and we just duplicate everything. Whatever is written, again, we just have manual test cases which we implement, and we just assume there's nothing. And then we write the API test. We usually skip them because, well, if I'm going to be testing CRUD, create, read, update, delete, for endpoint, I'm going to be doing the same thing again with end-to-end tests. So I will still basically cover the same thing. So there is no need to actually write separate API tests. So usually this is the case why API tests are being skipped. And we just trust and move all our testing to end-to-end tests. And we create a lot of test cases, and it creates a lot of maintenance and problems and flakiness. And this is one of the problems that when we start automating, what we do, we basically have some kind of manual regression test cases, and we move them to, we just blindly automate them. And the problem is that when you are testing manually, that's the only way how you can test them. It doesn't mean that you can write API tests, where maybe you don't use Postman that much. Maybe you don't use, you don't know what's in unit test, what kind of contracts are being written and tested. You assume that you're testing everything manually. And when you move to automation, you just brute force that coverage into automation. And this is not also not that such a great approach. And that's why we create a lot of technical debt, and the effort to automate is huge, and because of all of these problems. So I'm not sure what about you. Maybe you relate to those problems. Maybe you don't even know what's happening in unit tests and integration tests. This could be the case in your project or the company you're working with. And unfortunately, I don't have a recipe how to solve that. What I'm going to do, I'm going to just point out the things that is important. And because every implementation, every project is different, the competencies of the team is different, the approach have to be, different as well. You need to approach the custom problem with custom solution. And there is no silver bullet. There is no recipe how to do that. Just basically focus on the things that you want to do and be a problem solver. And use that human power, which is really hard to automate, and just be how you can solve this problem in your specific case and with your specific skill set and availabilities and tools. And the goal is just to make sure that the test automation is most efficient you can make it. And the full stack test automation is kind of like a theory. How can you approach the automation to make it more efficient? Yeah, so that's I guess that's a short version of the problems I've seen.
Yeah, you actually pinpointed things that I was aware of, and you put them to words. So what I hear is that for developers, they focus mainly on syntax, but not on semantics of what they're testing. So just the form is okay, it works, it communicates, but they don't look at what is the data actually that we're using and what is the value that it should deliver. And also what you mentioned about the testers then coming into play and having no idea of what developers actually covered and doing the same thing twice. that's also an issue that I didn't even think of, but it's actually very true. So thank you for pointing that out. And then you started mentioning the test automation efficiency. How would you solve that problem?
Yeah, so thinking about the name of the topic, so it wouldn't be surprised that we need to think as automation as a full stack. If we're doing automation, we don't need to. We should probably share that responsibility and think about what automation as a holistic, like one thing that we are like covering automation for the whole project, and not from separate perspectives. What developers are doing, what test engineers are doing, and then duplicating each other. And I guess one of them, like there are two different cases how we can start thinking about that. So let's start with the easy solution. So if you have a new project, which is just starting, and there's no technical depth like existing, so you can just do good practices and then keep them going. And there's not so much like what's slowing you down, and you can get better results. So one of the good practices would be to find advocates in the teammates. So if you are a test engineer, you won't be able to solve it alone. It's hardly the truth, and you need your other engineers, not only other test engineers, but other engineers like developers, business analysts, and DevOps working together in order to solve this issue. And this is the only way how you can do that. You need to find those advocates, and you need to start good practices. For example, if you are thinking that I want to automate everything, so I want to automate everything from when we are actually working on the user stories without creating a technical depth, because if you move automation in a month or two, it will be very hard to get back to that same context. What are you actually testing? What are the edge cases, and what you need to cover? It would be much harder to retrieve that context and get that information. So it's better to start automating as soon as you working on that. So basically look at what developers are doing, help them write better unit tests, and then build that trust what's already covered, so you don't need to create any kind of extra test cases or automate everything on end-to-end test layer, and just start to work on that issue. And I guess one of the biggest takeaway is that to make sure that the team is want to continuously improve. And it doesn't matter, it's going to be automations, it might be something else, but you continuously improve, and you know that there are some problems what we are doing. We're doing maybe some cutting corners, maybe doing something faster just to reach a deadline, but we know that we're doing something properly, and we need to think of ways how we can do it more efficiently. And there's a good rule that in every sprint you have to have at least 10-15% of your backlog from story point perspective need to have for improvements and this technical depth to clean up. And this can be used for always improving it. In this time it might be automation. We need to come up with better ways. We need to run it more often. We need to come up work together on user stories to have a better coverage on unit tests and integration layer, and so on. So it's kind of easy to start on a new project. There is a lot of technical depth. If you're working on an already existing project, it might be running for multiple years, and there might be a lot of technical depth. It's really hard to change something and see results, see what's happening, because it might be shadowed by the huge amount of technical depth, even though you're doing good things, but the technical depth is just still drowning you, and you don't see that the results that much that well. But still, you need to come up with you need to find a team who are advocates in each of the areas and can help you get better and write those improve the automation. So before you're starting that, you need to make sure that all the team is aware that there are some problems. If we know and we can say what are the problems, then it's easier to start changing them, because the teams is aware what is happening and what these improvements are for. So if everyone on the same page, that we know that, for example, automation is not very efficient, you can use the logic to make sure to pinpoint the issues. And then if we have that agreement with everyone that it's not perfect, when we can introduce some changes, and don't do everything from first day, all the changes are introduced and we're working on multiple changes. Start it slowly, depending on the team how they're comfortable with changes, but start slowly and maybe prioritize and start with the things which are easy to implement and would have a best result, like would have a most visible and valued or measured results. So start with those and then implement them like easy steps and biggest gain. So, and then the team will probably want to join that stream as well. If we see the result, we want to also be like helping out to make it more efficient. And then you can go and work with the bigger items, and it might take more time to do that. But the biggest problem, if you're a test engineer, you will need to start investigating code, and not only automation. You will need to understand the code of developers, and there's no way around it. If you want to help them write better unit tests, you need to read what they already have and pinpoint what can be done better. The end goal isn't that you start writing a unit test or integration test. The end point is that you can help them write better tests. You can do the code reviews, and you have a special skill that you are good at analytical skills. You're good at finding the edge cases, test cases, what can go wrong, and what kind of test I need to perform in order to make sure that the application is working and there is no issues in that. And by doing that, by sharing that skill in and moving it into unit testing, it's kind of a shift left approach where you can help them help you to get that coverage. And then you will know what's actually covered there. You will build that trust. You will already know what's in their code, what's is already tested, so I don't need to duplicate that. And the only way is to get there is just, well, understanding the code. And this is the kind of like a biggest obstacle, I would say, that's stopping us from actually doing that. But yeah, there's no silver bullet to that, and this have to be done. It might take you multiple days to actually look at the one unit test, make sure how it's working, in order to get the information, to understand what's happening, and maybe suggest some improvements, what can be done better. And it also depends on the quality of a code the developers are producing. So if they write well, not very readable code, if the name, function names and test case names are not very readable, it's hard to understand. If they're testing not the business logic, but actual implementation details, for example, specific function, variables, which have to be changed, like if you're doing some kind of like running function, the variable should change from true to false. Why? And there's a lot of this kind of questions which doesn't make sense, and you need to help them write test cases for business logic, testing business logic, not implementation details. And maybe asking those questions will raise those issues to the developers that, okay, maybe we're concentrating on the wrong things. But yeah, you need to start with reading the code and investigating that. So yeah.
Yeah, thanks. Again, some very interesting insights. And you also made me think of the keynote from Steve this morning, when code should be understandable. It was one of his things that systems should be testable. So also the code, the implementation itself should be testable, should be made simple, observable. So if testers can read code, that probably also indicates that the design is properly done. And it's also true that you can only solve a problem if you are aware of the problem. So I think that's also a takeaway for me. Who should be solving these problems?
Yeah, this one is tricky. Basically, in practice, I've seen both test engineers and developers doing that, like holding that flag and asking good questions. So I would say that anyone from the team who is motivated enough and have the competences to do that, and it could be even project lead, it could be a business analyst if he's technical enough, he then can drive why our automation is taking so long, why maintenance is so expensive, and start asking good questions, investigating what's happening, and then driving the changes to make sure that we're solving those problems. And yeah, I would say that anyone could do that from a team. But if you don't have expertise in one field, it would be much easier if you can find advocates from each layer. So for example, if you're a test engineer, you can find an advocate of developer who's really good, like he's very like open-minded, he wants to improve, he's seeking knowledge and want to be like producing better artifacts and like being best, like better, seek mastery in his skill sets, what he's doing. So you can collaborate with him and maybe explain him the problem, and he will come up with a solution. And it's much easier than for you to learn with programming all the intricacies. And basically, you need to find a team who will help you, lead that flag and do those changes. From test engineer perspective, I would say that they still need to understand what are the capabilities and what is done with unit and integration testing, because, well, frankly speaking, if you're writing end-to-end test, then you probably developers are writing all the tests, unit test and integration test they need, and then the front-end unit test and integration test they need, and they see fit. And whatever is left for API and end-to-end test, because, well, maybe they can be tested in those layers. And it doesn't mean that developers have to integrate what we are testing, but basically we need to know what's already tested. And it could be a readable form, it could be some kind of test cases. We can probably send them a checklist of things that we want to cover, things that we think that might be problematic. And if they can, like, this I can test, this I can test, this I can test in unit test. Oh, this one, it needs to be an API test or maybe an end-to-end test. And maybe then we can have a good list of understanding what's covered and what's not covered, so we don't need to duplicate that effort. And for test engineers, we need to have an interest and understanding of what's in unit test, and then try to reduce the amount of UI and API test required to actually increase the coverage that's already in there in unit test. And also helping developers implement more business logic testing inside the unit and integration test, because if they're working with code coverage and then only like line by line looking at what needs to be tested, maybe there is a function and then they pass true and then false. Oh, look at 100% coverage. What are you testing? What are you asserting there? It might not be even relevant. So there are things that we can ask a good questions. Well, what are you testing here? And it would be very valuable for them to grow as a specialist, because they will produce better artifacts, less buggy code, and then they will grow as a specialist in their domain as well. Then you have developers. For developers, I would say that they need to be open-minded. They need to be forthcoming that for example, if you're a junior developer, you might be willing to sacrifice quality just to deliver more points, because, well, points is something that you can maybe boast about at the end of a sprint. And maybe that could be the juniorish approach to developing software. For seniors, I would expect that they want to deliver quality product. They want to have less bugs found after whatever they developed. We want to improve the not the art but mastery, and that could be something that you can appeal to, like how can get better, how I can help them seek mastery. And for senior developer, if someone like junior test engineer approach them and saying that, hey, you need to maybe improve something, they should be open-minded and critical that maybe it makes sense. It's okay that junior is helping me grow as a senior. And I sometimes see that could be a bottleneck with this approach, that maybe not very open to others to help them. And just thinking how you can create better artifacts after you're done developing. Business analyst needs to can help to provide more understandable, full and unambiguous requirements, so that developers can develop the system better. In the first run, they know what all the edge cases, all the business logic, so it would be clear for them, and they can use that in order to write better unit test. So, and the business analyst should be willing to help and maybe change the way how we produce those requirements, in order for teammates to be more efficient down the stream, because they're going to start writing requirements. If that's going to be, well, not a good quality, don't expect some kind of magic happen down the line, then you will have a great functionality or feature. So this all starts in with the requirements, and they have to be top notch. For DevOps engineers or infrastructure or cloud architects, I would say that they need to be more proactive into offering what can be done. So we need to know what's happening in the projects in order for them to suggest better approaches. Like, hey, there is this kind of, I can automate that. We have some environments we can create on-demand environments. We don't need to have them dedicated where we deploy all the stuff. So I would expect them to be more proactive into helping the team understand what the problems they are having and automate them and help them create better solutions, because they are experts in that field. And I would want them to be more proactive into suggesting what can be improved. Yeah, so I guess everyone should be actually solving it. It's a team problem, and I think it's on the one hand it's good because like everyone needs to be working on that, and it's nice to be like doing teamwork in order to solve the problem. But on the other hand, it's almost impossible for a solo person to actually make it happen, unfortunately.
Yeah. So I hear it's the entire team that should contribute to solving the problem. It's not a one-man issue. And again, referring to Steve, go for pairing, developers sitting together. But I also hear you mentioning testers sitting together with developers. They learn from each other what to test and how to test, but also how to read code. The business representatives also pairing together with developers and testers. So it's always nice if things come back together over different presentations. Um, I have the impression that you have a lot of experience in this. So have you tried to solve this?
And it's yes and no. At my current role, I'm a testing like practice lead, so I don't have a lot of hands-on anymore. But I did had the chance to try out those ideas and like things that I see that could be wrong, and then help the team solve that. So we worked on one of a project which is wasn't new, so it was already developed, and we had to migrate from Angular JS to Angular, and basically it meant that we need to rework all the pages, and there wasn't any test cases, there wasn't any unit test written, so integration test, and basically it was kind of a blind test that you needed to make sure that functionality is working without even knowing and working with that functionality before, and so it was a good approach where we can test something, and I took the whole page, one page, dedicated page. So I wanted to try out this full stack test automation approach. So I took one page, and I explored it, and I found out all the functionality I could come up with, and I listed how we can test it, what test cases we can create in order to make sure that that functionality is working and nothing is broken. And then I had that full list. There was like 20, maybe even more test cases. I try to cross check them, what can be done with unit test, what can be done with integration test, front end, back end, then some maybe API testing, and then what's left with end-to-end test. And then I could like talk with the project leads, and from back end and front end, then we covered what's already tested, what we can create it, and there was some problems, and we had to adjust in order to support that kind of like business like behavior driven testing. So it's not like, it doesn't mean that you need to write them as like in a gherkin, but you need to understand what kind of things you're testing for, so that the user can like start using the system. So you're basically testing not the code but behavior, like functionality of a system. And they created some kind of like documents, how we improvements, how we approach unit and integration testing with all the guidelines, and we look at the code what's already done. We analyzed it. I pinpointed for the problems. Basically, everything what I mentioned before that was an issue with unit tests and integration tests as well. And then they created the document, and then everyone was starting using that approach, and then all the code reviews, every development when unit testing was involved was using that code review, like not document but approach how we write unit test. And basically it actually helped us improve that coverage in the lower level. And then we only had to write maybe a few API tests, and also end-to-end test. We only had to write one, and it was the actual end-to-end. So basically from dashboard you navigate to that page is opening up. If you have a table is with the data, it's loaded, and then there was one interaction. I wanted just to check that I can interact with the table itself, and just click on a table item, and then there's some pop-up module, and that's it. So that was the actual end-to-end test case where I need, as a user, I wanted to navigate to some kind of dashboard, and then like interact, look at the table had data, and then see what's happening there. And yeah, maybe there was only one or two test cases I had to write and then test. Everything else was done in other layers, and we can like, it was much easier, it was less flaky, and it was it didn't take that much time to actually test that page and then create that and then maintain it afterwards. And because developers but there was a nice bonus that developers, when we were writing integration tests in the front end, like in UI, not a end-to-end test, but integration test, they had to inject some kind of like locators, like test data IDs, and in order for them to test their own code. And that was so much easier for me to find those locators because we already like had injected items in them. So I didn't have to use like long XPaths, which are usually unstable. And every time when they change something, they refactor UI, they're probably going to leave those test IDs because we will need to change their integration test as well. So it's more likely that I will not need to change my test. So it's a nice bonus, which we found out while trying to solve that problem. And yeah, I think that was a great result. Like developers were really open-minded and they wanted to improve as well. They wanted to seek mastery, and then that helped them write better unit tests. And I think that was a win-win for everyone, and for testing and for product, and for, I guess, from money perspective, how much we actually spend on automating, that was a win as well. So we cut the cost on that one as well.
Yeah, I can definitely hear if you split it all up and you're not doing any duplicate work, of course, this will have a positive impact on your budget. And I like the idea that you mentioned of doing behavior-driven development without even doing the GURC, and just to understand what the system should do, that developers have a more perspective on what is the value, and not already, again, looking into the implementation or the implementation of test cases. Are there maybe other things that we can do to increase test automation efficiency?
Just before going to this question, I want to like add on to what you said. So with the behavior driven, it was very good to write readable test names, descriptions for what is testing there. And behavior driven, it was easier for developers to understand what they need to write, and for test engineers to read what's already implemented. So if I can find out what maybe test cases are missing, or what I need to add more, and they can just basically propose another test case just with the description without any kind of implementation details, and developers would understand what we need to implement. So it's easier for everyone to communicate without any kind of like implementation details, like what the function name, what the module names, what kind of variables we need to change, just basically the functionality, what needs to be done. And yeah, it actually added a lot of clarity to our communication with developers and test engineers. Yeah, so another thing what we can do with like efficiency improvement for test automation, I think if we have automation in place and we have like everything automated, for example, it's a kind of like missed opportunity. And when we run it only before release, like we have automation and we run it before releasing software to production, or maybe nightly. And this is kind of a missed opportunity because you have everything automated. It's there. You don't need to run it manually. And what we end up with is that if we have a feature developed, we don't run automation, like usually API and end-to-end test automation don't run it, and he uses manual testing to test the feature. And it could be broken, it could be not working correctly, and it could be that we are tested everything, but that feature broke somewhere else, something, and we need to refactor, we need to rework that feature in order not to break that other place. And maybe all our tests are bit pointless because the feature changed, the code for that feature changed, and if you don't retest everything, it means that you are assuming it's working, but it doesn't mean that it's actually working. So the best way is that if you have automation, all of that, you need to run it before you start manual testing or interacting with that application, exploratory or like feature testing. So one of the best approaches I've seen, that if you have a pull request, you create, like developer create a pull request, and on that pull request, you run all your tests. So while it's being reviewed, you already might have a results for your automation. What is there any issues? Is there any bugs? Is there anything wrong with that? So you would know that before even start testing. So you might skip all the retest, all the like registering bugs and all of those things. You can skip that, and developers can have that feedback faster. So even maybe he goes for a coffee after finishing feature and he didn't start another one. So he again comes back and he can start fixing that. Because if you don't have the time to test it right now, if you test it the next day or after 5 hours, probably developer will start doing something else. And then he will need to switch the context, get back to everything what's happening in that feature and then write it again. So it's a lot of time saving if you just run all of automation. Even though if you might save a half an hour per sprint, maybe an hour per sprint, it's actually, well, it doesn't cost that much because, well, it's only electricity, right? Maybe some cloud computing if you're using it cloud to run the test, but it's kind of almost free compared to the manual effort for a test engineer to test it and retest it. So I think efficiency could be on return on investment for automation. And I think I also seen that in a previous talk on this track, that you need to run it more oftenly. And if you can run it on every new build, that could be a good return on investment for automation, and it could pay off faster than you expect. So yeah, I guess that could be my advice and our advice how you can increase automation efficiency.
Yeah, thanks. Well in time, Nikolaj. I think you gave us quite some ideas to improve our test automation approaches. There are a lot of questions, and I think there will be more at the end because it's the end of your talk, the interview. Already 6 questions. I'm going over them. People can upvote them. So I'm going to start with the one who got the most votes. How to track your overall test coverage across the different automation layers? Would you use a checklist as a reference point to know when desired coverage has been achieved across the layers?
So this is only my personal opinion. So whenever you are creating coverage after the fact, so basically the feature is done, it's in production or somewhere else, and you only then start creating test automation for it, you already failed in a way. And every time when you want to calculate the coverage, is basically it's something that you can it's something that how you're trying to solve the technical depth, and you probably will never be accurate. So whatever you're going to count, if you need a number, sure, go for it, but it will not be accurate. It will be something that, well, it never be accurate. So my approach would be just to, when you have a feature, you test everything. You have automation done, and then the feature is done. So you know all the context, all the things that you wanted to test. All developers are still on the same page with the same feature. You know what's covered in unit test, then you cover whatever is missing with the API and end-to-end test. That's how you can have a good coverage. So all the requirements you can come up with for that feature, all the test cases, you can check them with the checklist. For example, cross check if everything is tested and some of the layers, and then you have a good coverage. That's 100%. If you're doing something that after the fact, implementing test automation, tracking coverage it's just a number. I don't trust that number that much that I don't even spend any kind of effort to calculate it. If the management requires a number, I can calculate maybe what kind of how many test cases I have in a backlog and how many test cases I already implemented, and that's the number. If you need a number, but basically it's so kind of meaningless. It's something like how we calculate with the code coverage. It's 100%, is it? But so when you start thinking about it, probably not. And the same thing with the coverage. If you don't do it on day one, when you're with the feature while it's being developed and before it's done, everything else is just you trying to catch it, and just it's never going to be a very accurate number. But yeah, if you need the number, depending on what kind of situation you are, you need to calculate that number with the best accuracy you can come up with. But you need to be realistic. It's not the real number. It's not like a tax or price with cents in place. It's something around 50%, around 70%. What it means, I don't know. Test cases.
Yeah.
So yeah, that's my approach. But.
Okay, thanks. I think we have time left for one more question. What about regression testing? How do you cover it? Do you cover it like end-to-end tests?
Yeah, so with regression testing, our goal is to make sure that the application is working as expected. If we have some kind of requirements that the functionality X should be like working, maybe some tax calculation, maybe specific rules, for example, for one country, for one state, it's another or different thing. So all of those things can be covered somewhere. And basically, you don't need to have manual test cases anymore if you have everything covered with automation. There might be some cases when automation is not feasible, and I also run into those cases as well in my practice, and it wasn't almost impossible or it wasn't feasible. So we just like uh, accepted that some of the things will need to be manually tested, and well, that's kind of fine. This is our decision. But still, reducing that effort to do manual regression, it's always a goal, and it's always there, it's always a cost behind it, and it's always frustration and stress, and it introduced so much things that so much like wrong things into our development cycle that we can't do continuous deployment. When we deploy everything that is done, you can deploy it to production if it's passing all the tests. If you have manual test, it's impossible, or you need to take a risk that you don't test everything and just expect that it will be working. So I guess manual regression is something that we target with automation to reduce. It doesn't mean that you're going to have zero of them all the time. I don't think it's possible, but you need to reduce it and save the money and save the effort for something more meaningful like exploratory testing. Yeah. But thanks for questions. I see there's much more questions. I'm not sure if we're gonna leave the studio. Is it gonna be like gone?
Yeah, we need to go for the next one. But I think the questions will still be available in Pine, or at least I hope so, so that we can take the time to answer them, maybe in a written way. Nikolaj, thank you for the very interesting talk, presentation, the interview. I really loved the format. It was really nice doing something differently. I like the lazy approach. It was very interesting. And I would like to invite all participants to join me in the next session within 5 minutes, a session by Paul Dragunis on CI/CD and so on. So thank you again, and hope to see you soon.
Yeah, thanks, Wim. It was a pleasure to have this interview. I also like the approach with the interview. Yeah, thanks.
Bye.
Bye, listeners as well.